Hello everyone, welcome to my channel. In this video, let's learn about modern periodic table. Okay, see under this we have arrangement of elements in modern periodic table, position of elements in modern periodic table and trends in modern periodic table. Henry Moseley in 1913 gave this modern periodic table. Before this, many other scientists have given classification of elements in their own way, but this modern periodic table is widely accepted one. So, how elements are arranged in the modern periodic table? Elements are arranged in increased order of their atomic number, whereas other classifications like Mendeleev periodic table, Newland octaves and Dobrenius triads, their elements are arranged in the increasing order of their mass number. But in the modern periodic table, elements are arranged in the increasing order of their atomic number. Okay, so this leads to overcome drawbacks of Mendeleev periodic table. Modern periodic law states that properties of elements are a periodic function of their atomic number, whereas Mendeleev periodic law states that properties of elements are periodic function of their mass number, whereas in the modern periodic table properties are completely based on atomic number, not on mass number. Now let's see how elements are arranged in the modern periodic table. Modern periodic table has 18 vertical columns known as groups and 7 horizontal rows. They are called as periods. Elements with different properties are arranged in different groups. Now we have 18 groups in modern periodic table. Okay, first and second group are soft metals. Elements such as lithium, sodium and potassium are soft metals. They belongs to group 1. That group is called alkali metals group. Okay, that groups are the elements present in that group are known as alkali metals. Next group contains beryllium, magnesium, calcium. They are known as alkaline earth metals. Second group elements are alkaline earth metals. Okay, and next third group to 12th group, they are transition metals. Transition metals means they are strong metals, hard metals. 13 to 18 are p block elements. P block has metals, non-metals and metalloids in it. Okay, and 3 to 12th group, they are d block elements. Transition elements are also called d block elements, and first and second group elements are s block elements. Elements arranged in the modern periodic table on the increasing order of their atomic number. Okay, and also elements present in the group, in particular group, they should have a same number of valence electrons. That means take example of lithium, sodium and potassium. Lithium, what is the electronic configuration of lithium? 2 1. Valence electrons are 1. In case of sodium, 2 8 1. Valence electrons in sodium also 1. Potassium 2 8 8 1. So valence electrons in all three elements are same. What is meant by valence electrons? Valence electrons means these are the electrons present in outermost shell. Electrons present in last shell or outermost shell is known as valence electrons. Whereas in case of periods means horizontal rows. That means left to right. Elements from left to right are known as periods. That is known as periods left to right. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon belongs to second period. In periods, number of shells remain same. Example, lithium. Lithium have 2 shells. Beryllium will also have 2 shells. Boron 2 shells. But here number of valence electrons will increase when you move from left to right. That means lithium have 1 valence electron, beryllium have 2 valence electron, boron have 3 valence electrons in their outermost shell. But what about shells? Number of shells remain same across the period. This is about arrangement of elements in the periodic table. Now let's see how to find position of elements in modern periodic table. In order to find exact position of element in the modern periodic table, first we should know atomic number of that particular element. For example, sodium. If I tell you to find the exact position of sodium in the modern periodic table, you must know atomic number of the sodium. Then you have to write electronic configuration of sodium. What is the electronic configuration of sodium? It is 281. Understood? 281 is electronic configuration of sodium. So how many shells are there in the sodium? There are 3 shells, isn't it? K shell, L shell and M shell. So sodium contains 3 shells.
Periods of an element is identified by number of shells. Okay, so sodium has 3 shells, so sodium belongs to third period. Now how to find out group number? Group number is identified by number of valence electrons. How many valence electrons are there in sodium? 1 valence electron. So sodium belongs to first group and third period.
Let's take another example, aluminium. What is the atomic number of aluminium? 13. When you write electronic configuration, 283. So it contains 3 shells, K, L and M. So it belongs to third period. But when it comes to group number, aluminium is 13th group element. So outermost electrons are 3. So we have to add plus 10 to that valence electrons. If valence electrons are 3 or more than 3, then we have to add plus 10 to that. So now aluminium belongs to 13th group. Same thing in case of nitrogen, oxygen and sulfur also. Take example of nitrogen. Nitrogen atomic number 7. So its electronic configuration 2, 5. So here it belongs to second period because number of shells are 2. When it comes to group number, since valence electrons are more than 3, add plus 10 to that. Now it is 15. Nitrogen belongs to 15th group. In this way, we can find out exact position of elements in the modern periodic table. Trends means some characteristics, how do they change down the group and across the period. So we have some trends such as valency, atomic size, metallic and non-metallic characters and nature of oxides. These are the trends we are going to learn in this lesson. So first thing, valency. How do valency vary down the group and across the period? Down the group, valency remains same because number of valence electrons remain same. Okay, valency is decided by number of valence electrons. So number of valence electrons, if number of valence electrons remain same, then valency will also remain same down the group. But across the period, first valency will increase, then it will decrease to 0. Next trend is atomic size. So atomic size will increase down the group, atomic size will decrease across the period. Why down the group atomic radius will increase or atomic size will increase? As we move down the group, number of shells will increases. As shells increases, atomic radius increases. So down the group atomic radius will increase. Across the period, number of shells remain same. Okay, across the period number of shells will remain same, but number of electrons will increase. Number of electrons will gradually increase across the period, so that as number of electrons increases, force of attraction between nucleus and outermost electron will increase, so that atomic size will shrink when we move left to right. Across the period, atomic size will decrease, whereas down the group atomic size will increase. Next trend, metallic and non-metallic characters. Metallic and non-metallic characters is depending on how an element will lose their outermost electrons. So as we move down the group, metallic character will increase because As atomic radius increases, force of attraction between nucleus and outermost electron will decrease. So if there is no force of attraction, then we can easily remove an electron from its outermost shell. So tendency of losing metals have good tendency to lose electron. As we move down the group, tendency of losing electrons will increase. So down the group, metallic character will increase. Now let's compare metallic properties with some metals. Example, lithium, sodium, potassium, rubidium and cesium. So all the elements in this group are metals. So when you compare metallic nature, when you compare metallic nature with lithium and sodium, sodium is more metallic than lithium because sodium can give up its electron more easily than lithium. So like that, in this group, lithium is least metallic, cesium is more metallic. When it comes to non-metallic nature, as we move across the period left to right, non-metallic character will increase. Okay, why non-metallic character will increase? As I told you, shells remain same and number of electrons will increase. A number of electrons will gradually increase across the period. So as number of electrons increases, effective nuclear charge will increase across the period, so that they have tendency to gain electrons instead of losing. So non-metallic character will increase across the period, whereas metallic character will increase down the group. These trends will also help us to predict oxide nature of elements, whether the oxide of an element is acidic or basic. So as metallic character increases down the group, basic oxide nature will also increase down the group. Across the period, acidic oxide nature will increase. This is all about modern periodic table and position of elements in the modern periodic table and trends of in modern periodic table. If you like this video, please do like, share and subscribe to my channel. Thanks for watching.